Hi friends, welcome to a co-engineering YouTube channel. Today we discuss about electric flux. Electric flux is orientated on positive charge and terminated on negative charge. In electric flux is originated on positive charge and terminated on negative charge. In absence of negative charge of flux, psi terminates at infinity or infinity. Psi is equal to q coulombs. If D is the electric flux density existing in the electric flux lines, then electric flux psi through any tube. Psi is equal to dA. Here D is equal to average flux electric flux density. Here D is equal to average of electric flux density. Here psi is equal to electric flux. A is equal to area of cross sectional of the flux tube. Here if D is the electric flux density existing in the electric flux lines, when the electric flux density is existing in the electric lines, then electric flux psi through any tube, then electric flux psi is passing through any of the tube. The equation is psi is equal to dA. Here D is average electric flux density. Here A is the area of cross section of the flux tube. Psi is electric flux. Now electric flux density D is equal to, here the vector D at any point is a function of charge Q and its position with respect to the charge or R only, and is called electric flux density. What is electric flux density? Here the vector D at any point is function of charge Q and its position with respect to charge is R only, and is called electric flux density. If it consider the area ds, for that area electric flux density always perpendicular to that and its direction of normal vector to that perpendicular area. Sometimes electric flux density D is also called displacement vector. Sometimes electric flux density is also called as displacement vector D, and flux associated with it is known as a displacement flux, and flux associated with it is known as displacement flux. It has the unit of coulombs per square meters, coulombs per meter square. The charge q is distributed throughout the volume. The charge q is distributed throughout the volume. Then if you take small area ds within the volume, then electric flux density perpendicular to the area. The charge q is distributed throughout the volume. If you take small area ds within the volume, the electric flux density perpendicular to that of area. It is vector quantity, the same direction on the electric field intensity vector at the point is d is equal to epsilon E is a vector quantity. That's why the same direction of electric field intensity vector at the point is d is equal to epsilon E. If d is equal to epsilon E, d is equal to epsilon E is electric field intensity vector. The point is d is equal to epsilon E. Here D is equal to epsilon E, where D is electric flux density centimeter by coulombs by meter square, centimeter by meter square. Here E is equal to electric field intensity V by M. Epsilon is equal to permittivity of the medium, force by meters, force by M, F by M. D is electric flux density C by meter square. E is equal to electric field intensity V by meter. E is equal to epsilon is equal to permittivity of medium F by meter. D is equal to epsilon into Q by E value is Q by 4 pi epsilon into R square AR bar in air medium. D is equal to Q by 4 pi R square AR bar. Okay, Nandi, this is electric flux density. D is equal to Q by 4 pi R square AR bar. if surface element ds it makes an angle theta when surface of element which is a surface element which makes an angle theta make an angle ds which makes an angle theta with the normal of this point of direction, then the differential flux crossing the element area. The differential flux is one of the differential flux is crossing the elemental area. Here d psi is equal to dds. Here d psi is equal to capital D ds cos theta. When theta is equal to 0 degrees, cos 0 is 1, cos 0 is 1, cos theta is equal to an, d psi is equal to d ds, cos theta value is value and then cos 0 degrees, cos theta is 0, the value is 1, cos theta is equal to an bar. That's why dou psi is equal to d dot capital D dot ds. Dou psi is equal to capital D dot ds. Here, the electric flux density for different charge distributions. Electric flux density for different charge distributions, though are line charge, surface charge, volume charge. Okay, friends. Now, the line charge, electric flux density for different charge distributions. There are different charge distributions of four types: line charge, surface charge, volume charge. Now, we discuss the line charge and surface charge and volume charge. From a line chart, the electric field intensity is given by dq is equal to rho l dl. Q is equal to integral rho l dl. The electric flux density is given by substituting equation 1 in d is equal to q by 4 pi epsilon naught 4 pi r squared a r bar. Q value is integral of rho l dl by 4 pi r square a r bar. This is the line charge, electric flux density of the line charge. Here, electric flux density of surface charge is nothing but surface charge distribution. The electric field intensity and electric flux density is given by d is equal to integral of rho s ds by 4 pi r square a r bar. Now, similarly, the volume charge for volume charge distribution, d is equal to integral of rho v dv by 4 pi r square a r bar. These are the electric flux density of different charge distributions: line charge, surface charge, volume charge. From line charge, d is equal to integral of rho l dl by 4 pi r square a r bar. From the surface charge, d is equal to integral of rho s ds by 4 pi r square a r bar. From the volume charge, d is equal to integral of rho v dv by 4 pi r square into a r bar. This is electric flux density of charges, electric flux density of different charge distributions. Thank you, friends. Thank you very much.